Welcome back. In this lecture, we'll cover discounting cash flows. Let's start this discussion with an example. Which of the following cash flows would you prefer? You have two options, $100 now or a promise of $100 a year from now. And why? Definitely you will prefer $100 now, and there are at least three reasons behind your decision. First of all, expected inflation. It is better to receive $100 now because value of money decreases over time because due to inflation. So you will always prefer to receive $100 now. Secondly, risks. If you receive $100 now, money will be in your pocket. But if there is a promise of $100 a year from now, this is always risky because future is uncertain and we do not know what will happen in our future. And finally, opportunity cost. If you receive $100 today, you will get the opportunity to invest your money and grow your money. But $100 a year from now will lose the opportunity to invest over the one year time. Finally, we can say that we cannot directly compare cash flows that occur at different points in time because of inflation, risks, and opportunity cost. Now, there is a solution to this problem. We can use discounted cash flows technique to find out the present value of future cash flow, which is also known as time value of money. The formula to find out present value is PV, which indicates present value, divided equal to cash flow divided by 1 plus R to the power n. R indicates discount rate and n is the number of period. This results in future cash flows being expressed in terms of their present value today. Here is an example. Let's look at this example. What is the present value of $100 expected in 1 year time, and your discount rate is 5%. So you have to find out the present value of $100 which will be received in 1 year time, and your discount rate is 5%. So we know the present value formula. Present value is equal to cash flow divided by 1 plus R to the power n. So our cash flow is 100, discount rate is 5%, so 1 plus R, which is 1.05 to the power 1. N is 1 because the money will be received in 1 year, and the present value of $100 is $95.24. What is the intuition here? Alternatively, we can say that if you have $95.24 and if you invest this money, that means $95.24 with 5% interest rate for 1 year, after 1 year you'll receive $100. Now, what will be the present value of this $100 if you receive this money after 2 years instead of 1 year? In this case, you have to change the n. So 100 divided by 1.05 to the power 2, and your present value will be 90.70. So let's look at what is the intuition. From here we can say that present value of $100 after 1 year is higher than present value of $100 after 2 years. So if you receive money sooner, your value of money will be higher. Now let's compute future value. So to compute future value, we can do compounding. So when you find our present value, we do the discounting. To find out future value, we need to compound present cash flows to the future. Let's look at an example. What will be your future value of $100 for after 2 years if your discount rate is 5%? the formula to find out future value is equal to cash flow into 1 plus r to the power n. So here cash flow is 100 into 1.05. 0.05 is the discount rate, 5%, which is 5% to the power 2, because you will get the money after 2 years. So in this case, future value is 110.25. So if you invest $100 with 5% interest rate, after 2 years, you will receive $110.25. Why would you want to do that? Because if you want to analyze how much you will receive after your retirement, you always need to find out the future value of your investment in terms of your pension or other investment. So we can also express present value and future value in this way. Present value is equal to future value divided by 1 plus r to the power n, or future value is equal to FV is equal to PV into 1 plus r to the power n. Now, how do we choose the discount rate? When we choose the discount rate, we need to consider several factors. So these are risk-free interest rate. We can consider the interest rate of treasury bill as a risk-free interest rate. We also need to consider rates of return on similarly risky investment when we calculate discount rate or R. In the meantime, we need to consider risk premium, opportunity cost, and expected inflation. So from here, we can say that greater the influence of these factors, that means risk-free interest rate, risk premium, opportunity cost, and expected inflation, the smaller the present value. Let's look at another example. So over here, your cash flow is 100, but instead of 5% discount rate, you will use 15% discount rate. So if we use 15% discount rate, present value of your $100 will be $82.82, which is much lower if your discount rate is 5%. Let's look at the summary. First of all, cash flows expected to occur at different points in time aren't directly comparable. So we need to consider risks, opportunity cost, and expected inflation if cash flows are generated in different points in time. Discounting expected cash flows back to their present value solves this problem. And finally, discounted cash flow analysis is the basis of the most popular project evaluation methods. That's all about this lecture. In our next lecture, we'll cover forecasting cash flows.